Hi there. Well, now we're going to look at polynomials in this chapter 5. This video is going to be about 5.3, actually through 5.6. And it basically is quite a few terms, which we're going to learn here. So let's go ahead and get started. We have definitions. We have a term. Now, a term is an individual piece of a function. That sounds confusing. They can be just numbers, like a -2, or variables like x, a product of numbers and variables. So a term is just a group. And when we start looking at examples, I think that that'll make more sense. It's just a group, and it can be x, y, z's. It can have multiple variables. They're all multiplied together. When we have just one group, it's called a monomial. And a monomial is a specific type of term. It is a term that is a product of constants and or variables with positive integer powers. And you can't have any variables in the denominator, and you can't have any square roots. And we'll look at some examples. Again, it'll make more sense. A polynomial, poly meaning many, mono meaning one. So a polynomial is many of our monomials. So you've got many terms rather than just one term. And it's the sum or differences of individual monomials or terms. And sometimes a polynomial, we can have a binomial, and that means we just have two terms. Or we can have a trinomial, which would be three monomials, or usually I just call them terms. Now, the degree of a term, and the degree is actually important. It's got some significance in how the picture of the solution looks, the graph, how many solutions there are if you set it equal to 0. So the degree is kind of important. So we have the degree of a term, and we'll look at some examples. It's going to be the highest power on the variable. And then the degree of a polynomial, you take that term that has the highest degree. Individual monomials, you look at those and determine, okay, which one's the largest? That's the degree of the polynomial. The leading term, the term that has the highest degree. And the leading coefficient is the coefficient of the leading term. Again, all of these will make a lot more sense when we look at some examples. All right, so first, which of the following are monomials? Okay, so a monomial can just be a number. So this is yes. A monomial can just be a variable. A monomial can be a multiplication of both, of 2 and a variable. Yes. A monomial cannot have a variable down here. And it's important that when I say a variable, so this is no. However, 1/2 x is yes. So you can have a number down here, but no variable in the denominator. You can have a number, just no variable. So this is a no, it's not a monomial, and this is a yes. It has a variable down here. This is a no. This right here, everything's in the numerator. The variables are all in the numerator. There's no square root. So this is a yes. I want to add one, and that's with a square root. Oh. I do my, if we have 3 square roots of x, all right, this is no. No radicals either. And you can't have a variable in the denominator. Their graphs are different. So, all righty. Now, polynomials, we put monomials together. Which of the following are polynomials? Well, our first definition was a term, and these right here are considered terms here. Now, is this term a monomial? Yes. Is this term a monomial? Yes. Terms are separated, monomials are separated by plus or minus signs. Those separate them. So this is a monomial, this is a monomial, so yes, this is a polynomial. Okay, so in other words, all of the terms need to be monomials. None of the terms can have an x in the denominator or a square root. If you look at the whole thing and there is not an x in the denominator, there's not a square root, then it will be yes. So here, this one, if you look across, this has 3 terms. Okay, this right here, x is in the numerator, x is in the numerator, it's just a number. The x's are not in the denominator, there's no square roots. So yes, this is considered a polynomial. Well, let's talk about both A and B again. A has 2 terms. So because it has 2, and we know it's 2, it's separated by plus signs or a minus sign. If it has 2 terms, there are times when we'll call it a binomial. It's a polynomial, but we can also call it a binomial because it has 2, bi being 2. If you look at B, it has 3 terms. Okay, they're separated by these plus or minus signs, 1, 2, 3. And it's a trinomial. It's also a polynomial, but we can call it a trinomial. You could call it a polynomial if you wanted to. It's not wrong. Let's look at C. Looking at the terms, we've got one here. So far, so good. This one actually didn't print out very well. With that X down there, it is not a polynomial. No. All right. So it would be a no. All righty. Let's look at D. It is a polynomial. All right. It's got just one term. We could call it a monomial, just like we could call this one a binomial and this one a trinomial. So this would be yes. The variable is not in the denominator, no radical. It's a monomial, and it's also a polynomial. This one is no. All righty. Okay, now let's take it apart and look at each individual term and what each individual term means. And that's what we're going to do in the next example. Now that we know how to identify a polynomial or not, now we're going to look at polynomials in general and talk about each of their terms. Let's look at the first one here, the term. This one has 1, 2, 3, 4, 5 terms, 5 parts that are separated by plus or minus. The first term we're going to put is 3x squared. I'm just going to list them before we talk about coefficients and degree. Our next term is a minus 8x cubed. Notice I put the negative in front. So you do have to put the negative in front. If it's a subtraction, it stays with with that term. The next one, 5x to the 4th. So far, so good. The next term is 7x. And our last term is a minus 6. Okay. Now we're going to look at the terms separately, and we're going to talk about coefficients because we're going to be using this terminology and some of the stuff, especially when we do division. So here, the coefficient is the number in front. So the coefficient of this first one is 3. The coefficient of this is a -8. Got to have the negative. The coefficient of this term is 5, just the number in front. The coefficient of this term is 7. And the coefficient of the last term is a -6. That is the coefficient. Let's talk about degree. The degree is the highest exponent on that term. So the degree is 2. The degree is 3. It's the exponent on that term. The degree is 4. And the degree, if it's not there, it's a 1. The degree here is 0. You could write x to the 0 because we know that's just 1, -6 times 1. So we're not changing the value, but it's 0. All righty, so those are the degrees. Now, one thing they wanted here is to identify the leading term. Now, the leading term is the one with the highest exponent. It's the highest degree. So this one here, 5x to the 4th, is our leading term. And normally, they may want you to write this in decreasing order, and we'll do that here in a minute. The leading coefficient is 5, and the degree of the polynomial is this highest power. That's 4. So it's the highest exponent. And the degree of the polynomial comes from the leading term, always. So this right here, 4 is the degree of the polynomial. All righty. So we have our leading term. There are times when they want you to write it in descending order or degree. So you would write 5x to the 4th. Then the next one is the 3. Then the next one is the 2. They're squared. And then plus 7x. And then -6 is our last. Okay. In order of degree. All righty. So hopefully that straightens up some of the questions maybe you might have on some of the terminology. All righty. Now the degree, like I say, it has some important factors. I know that if I were to set this equal to 0, I would have at most 4 solutions, at most. You might have 2 solutions, or you may have 1 solution, but at most you can have 4 solutions. So, it's got some significance there. It also tells you the basic shape of the picture of your graph. And because this is an even power, it would be shaped more like a parabola shape overall. Okay, so it has some significance to that the degree of the polynomial. Right now, we're just trying to find the degree. Not really like what's it used for yet. All right, so what we're going to do now is we're going to add some polynomials, and these will all be polynomials. They're not going to trick you and say, oh, it's not, you can't add them. They're not polynomials. So we'll deal with the non-polynomials in chapter 7. We'll start with those. But here, because this is a plus sign between my 2 parentheses, you can drop the parentheses, or you can just in your mind pretend that they're not there. So what we're going to do is we're going to add what's called like terms. Like terms have the same degree on them. So, and the variables match exactly. So in other words, I've got a -5x cubed, and I have a 4x cubed, which gives it, so you can combine the numbers in front. So a -5 plus 4 tells you how many total x cubes I have. Well, a minus 5 plus 4 is a minus 1 x cubed. I won't put the 1 in. And I got that by minus 5 and 4 is a minus 1. That takes care of my x cubes, and sometimes it's nice to cross them off so that you know they've been used. Our next one is our x squared. After the x cubed, our leading one, we go to x squared. Well, there are no other x squareds, so it stays by itself. We took care of that one. Then we have a plus x, but there are no other x's. Like there's not a 2x or a 1x or a 5x. That's the only one in the entire problem here, so it stays by itself. Then we have the minus 1, a degree of 0, and a 2 with a degree of 0. So I can combine those two and come up with plus 1. Negative 1 plus 2 is 1. That is your answer. You combine like terms. You've simplified it. And then it's going in order of descending degree. All righty, let's look at another one. Again, I have a plus sign in between. It's important, that symbol right there. If it's a plus sign, I can just kind of drop the parentheses and just start combining like terms. Let's do that. I've got some fractions, but that's okay. 2/3 x to the 4th. Another x to the 4th is right here. So I will combine the coefficients in front. 2/3 plus a negative 1/3 is positive 1/3. X to the 4ths. That's how many x to the 4ths I've got, combining those like terms. Then next would come a cubed. If you don't have any, you would just go to the squareds. And if you have trouble with fractions, just let your calculator do it. So let's go with our x cubed. It looks like that is the 5x cubed is the only one. So it has to stay by itself. So we just have 5x cubed. Okay. Now let's go to the x squared. I have a positive 3x squared and a negative 3x squared. Well, 3 plus a negative 3 is 0. They're gone. All right, we won't even write them down. They're gone. They add up to 0. So let's go to, so those are the x squared. Let's go to the x's. A minus 7x's and a positive 3x's is a minus 4x's. You don't add exponents because we're adding, we're not multiplying. The only time you add exponents is when you're multiplying them. We're just adding them. Okay, that takes care of those. And then we have a positive 1/2. It has a degree of 0, so we can add it with any other constants. It's most time we just call them a constant. So we'll take this constant, 1/2, plus a negative 1/2 is 0. So we don't put it in, and there would be your answer in descending order of power. All right, so that's kind of a quick rundown. We're gonna keep working on that of combining like terms. But what we're now going to do is, rather than have a plus sign, like I say, a plus sign, you can just kind of ignore the parentheses and just start combining like terms when their variables and their exponents match. You combine the coefficients in front. But if there is a subtraction, okay, if there is a subtraction, you leave the first one alone, all right, because there's not a subtraction out here. Plus x cubed minus 2x. Okay, we're going to rewrite these. We didn't do the ones up above, but we're going to rewrite this one. This becomes a plus, and you change all of the signs in the following parentheses. So this is a plus. This will become a positive 2x to the 5th minus x to the fourth plus 4x cubed plus 3x squared. And now it's just like the ones above. You just combine like terms. So when you have a negative outside the parentheses, actually it's like taking a -1 times everything in the following parentheses. You could think of it that way. It just becomes a positive. You do need to do that. All right. And then you change all of the signs in the following parentheses. And now you combine like terms. Well, let's go through that. Our highest power is x to the fifth. We have these two here. 9 and positive 2 is 11x to the fifth. We have an x to the fourth. It's by itself. So we're just going to have to leave it by itself. We have a 1x cubed. And again, we don't put that there, but there is a 1x cubed, and a 4x cubed gives us 5x cubes. A minus 2x squared and a plus 3x squared gives us 1x squared. And we don't put the 1 in. It's not that it's wrong if you do, we just don't. Looks like we just have the plus 4. It's our only constant. There are no other constants to add to it. All right, so we have this polynomial. It has a degree of 5 is the polynomial, the highest one. There's 5, possibly 5 solutions if you set it equal to 0. And we've got 11 as a coefficient, a -1, 5, 1, and 4, and it's in descending order. Perfect. Let's do another one. Here, again, the first one stays the same. We'll change this to a plus. That'll become a minus 3x to the fifth. Inside is positive, so now it's a minus, plus 4x cubed minus 5. So that changed all their signs. And what some people will do, rather than do this plus a negative, they'll just make it a minus. They'll just use a subtraction. And that's fine. Or plus a negative if you want to stay consistent. Depends on how much algebra you've had already. Okay, let's go ahead and combine our like terms. 5x to the fifth, negative 3x to the fifth gives us 4x to the fifth. Positive 4x cubed, and a 1x cubed gives us 5x cubed. There were no x to the fourths, so I just kind of skipped x to the fifth, or x to the third. And we have a minus 9x and no other x to the firsts. Minus 5 is our only constant. So there's your answer. The degree of this polynomial is 5. All right. I think that might be enough examples for you. Just change this to a plus and then change these signs and then combine your like terms. I don't want this video to get too long, like the last one. All right. Okay. Rather than add and subtract, which is what we did, we're now going to multiply. Now, first off, here we're going to multiply two monomials together. And we're going to follow the rules that we learned in the last section, sections 1, 2, and 3. That when you multiply the product rule, you add exponents. So this will be 30x squared. 1 plus 1 is 2. So you add the exponents. 1 plus 1 is 2. This one, 3 times a -1 is a -3. There's a 1 there. 1 plus 1 is 2. -3a squared. So those are 1s there. And you add them using our product rule. Okay, C, -7 times 4 is a -28. X, 5 plus 3 is 8. Okay, so we're multiplying some monomials together and we get a monomial. All righty. So now we're going to take this monomial, you can think of it as a monomial, times a binomial or times a trinomial. In order, when you have one out here, we're going to use what's called the distributive property. And we're going to take the x times everything on the inside. So, problem. People get this one with a plus or a minus sign mixed up with this one where there's no plus or minus. They'll want to take the 5 times the 6 and the 5 times the x. You don't do that. The only time you use our distributive property here is when you have a plus or a minus sign. Then you use your distributive property. So, getting that cleared up, we're going to take x times x times 3. X times x is x squared because you add exponents when you're multiplying. 1 plus 1 is 2. Plus x times 3 is 3x. And you're done. You can't simplify that anymore because they're not like terms. You got a squared, and sometimes we call that a linear term or x to the first. Let's try the distributive property. We're going to use the distributive property because we have these plus or minus signs. Whereas up here, we don't have it, so we just multiply the numbers in front and then add the exponents. All right, so let's go through this one. We're going to take 5x times this, 5x times this, 5x times this term. So the first one gives us 10x cubed because 1 plus 2 is 3. You add exponents when you're multiplying. 5 times a minus 3 is a minus 15. 1 plus 1 is 2. 5x times a positive 4 is going to be 20. 5 times 4x. And you're done. Okay, the distributive property. Now let's look at multiplying. Okay, so rather than just a number outside or a monomial outside, now we're going to make them look like this. Okay, there's a couple of ways you can do this. One is with a FOIL method, which they have right here. Another is using the distributive property twice. So when you do these, most people like the distributive property twice, but I want you to be familiar with the FOIL method because we're going to be referencing the FOIL method quite a bit in chapter 6 when we factor. So, I mean, you don't have to use it, but try to be familiar with what does the F stand for the O, the I, the L. So let's look at this first one. I'll go ahead and use the distributive property because people like that, and then we'll look at the FOIL. What you would do is you would take x times x. So you take the x times both everything in the following parentheses. Then you're going to take 5 times both of them in the following parentheses, and then you combine like terms. So let's start with the x. X times x is x squared. X times 4 is plus 4x. I just took the x times both of those, just like we did up here. X times both of them. Then we'll take the 5. So plus, because positive times a positive is a positive. So 5 times x is 5x. 5, a positive 5 times a positive 4 is a positive 20. 99% of the time, you'll be able to combine those in front. Okay, that's actually the O and the I in FOIL. Not those two in the middle, sorry. So that gives us x squared plus 4x and 5x is 9x. And you do need to finish it. You get 20. So that is using the distributive property twice. And sometimes you can do it 3 times, just all depends on how many terms you have in each of your parentheses. but let's use the FOIL method real quick. Let's talk about the FOIL, just so that you're kind of familiar with it a little bit. Okay. The F stands for the first times the first. So we're going to take X times X, the first in each of the parentheses. X times X, so our F is going to be X squared, okay? So we have an X squared. I'll put it down here too. The O is the outside. The I is the inside, and you multiply those little smiley faces. Some people do rainbows. Maybe you've heard of those. But the O, okay, is 4x. 4 times x is 4x. The inside is 5x. You multiply those, and you always add them together. The O and the I's, the outside and the inside. So we took the first times the first, and now we do the outside and the inside. That gives us 9x's when you combine those. And then the L is the last in this parentheses times the last in this parentheses. Was 20. Okay. So you have a couple of choices here. You can use the distributive property twice, or you can use the FOIL. First times the first, the outside, the inside, you multiply them. Multiply, multiply, and then combine them. 5x and 4x is 9x. The L is last times the last in the parentheses. Now you can only use the FOIL with 2 binomials, so I guess it has its limits. If you have more, if you have a trinomial you're multiplying, you have to use this distributive property method. So, all right, one moment, please. Okay, I had to stop for a second, so let's go ahead and let's go through this one. We can use, I don't know, most of you probably will use the distributive property. Maybe we'll just do it both. All right, so we're going to take the 4x times both terms in the second parentheses. So we take 4x times x is 4x squared. 4x times a minus 2 is a minus 8x. Then we'll take a minus 3 times this, minus 3x. Minus 3 times a minus 2 is a positive 6. A negative times a negative is a positive. So this gives us 4x squared minus 11x plus 6. These two are similar. Minus 8 and a minus 3 is a minus 11. And there's your answer. Using the FOIL, we take, I'm going to copy them again so they don't have so many arrows like they do up at the top. Okay, we take the first times the first, which is 4x squared. The first term in each of the parentheses, adding exponents. Outsides, the 2 outside ones is a minus 8x when I multiply them. Multiplying the insides is a minus 3x. That gives us a minus 11x. Last in this parentheses times the last in this parentheses, that's the L, gives me a positive 6. So you're done. Okay, let's turn the page and see what we've got over here. All right, it's just a couple of these multiplying. I think we'll just do a couple here, but you've got a trinomial times a binomial, so you'll need to use the distributive property. I think it's a lot easier to take this times everything. So take the smaller number times everything here, and then take the 4 times everything. So let's take, because you know you can multiply this backwards. Order doesn't matter in multiplying. X times x squared is x cubed. X times 2x is a positive 2x squared, adding exponents, knowing there's ones there. X times a minus 3 is a minus 3x. Now we're going to take the 4 times everything. The 4 times this, the 4 times this, and the 4 times that. 4 times x squared is 4x squared. 4 times a positive 2x is a positive 8x. 4 times a negative 3 is a negative 12. Don't stop here. You're going to have to see if there's any like terms you can combine, and it does look like we have some. We have an x cubed by itself, no other x cubes. A 2x squared and a 4x squared is a 6x squared when you combine like terms. And then we have a negative 3x, we took care of those, a negative 3x and an 8x is 5x minus 12. Now you're done. Now you'll get full credit. Okay, now if you don't like this going backwards, okay, you can rewrite it and put the one with the smaller terms in front. Times 5x to the 4th minus 2x squared. I just rewrote them, you know, because, you know, a number like 5 times 3 is 15 and 3 times 5 is, so order doesn't matter. So I'm just going to switch them. So now I'm going to take this x squared times everything in here. X squared times 5x to the 4th is 5x to the 6th. I'm multiplying. I'm taking this times this, and this times this, times this. So I'm adding exponents. X squared times a minus 2 is a minus 2x to the 4th, adding exponents. X squared times a positive 3 is a positive 3x to the 3rd, adding exponents, knowing there's a 1 there. Now I'm going to go back. I think I might erase my arrows. Well, I can put them on top here. Up here, up here, up here. 2x times 5x to the 4th is a positive 10x to the 5th. 2x times a minus 2x squared is a minus 4x cubed, adding exponents. 2x times 3x is 6x squared. Use the distributive property twice. And now we just combine our like terms. We have a 5x to the 6th, our leading term, degree of 6. We have a 10x to the 5th. We just have one of them, so it stays by itself. We have 1 of the 4ths. Here we go. 3x cubed and a minus 4x cubed is a minus 1x cubed. And then we have plus 6x squared. All righty. So that kind of gives you an idea of how to multiply these. Now, this last example, I'll just kind of talk you through it. Or even this one, you would take 3x times everything, 5 times everything, and combine your like terms. Here, you'll take 5t squared times everything, minus 1t times everything, 1 times everything, and then combine your like terms. All righty. Okay, that finished up this section. And what we're going to do is this next section is very well related to what we just did. Again, it's finding the products here. Seems like quite a bit. But, you know, you could just use your FOIL or your distributive property twice. But we have some special ones, and that's what we'll talk about here. Here, it even has a title on 5.6, special products. And there's 2 of them that are special. This first one that we're going to talk about is what happens if in the parentheses, they're exactly the same, except their signs are different. One's positive and one's negative, and they don't it doesn't matter which one's positive. You could have the negative here, the minus here, and the plus here. It doesn't matter as long as one's positive and one's subtraction. Well, let's look to see what happens. Okay, if we take x, let's use our FOIL. The first times the first, we get x squared. When we take the outside, we get a minus 4x. When we multiply the outside numbers, the inside is a positive 4x. When you add those together, they add up to 0. Now, will this always happen if everything matches, this x and x, 4 and a 4, but they're opposite? Will this middle term always drop out? Yes. So it can speed things up a little bit if you realize that what you have is called the difference of 2 squares. And one of them has to be a difference and one has to be a plus. And so what you do is you can skip the OI and FOIL and just go the first times the first, the last times the last, and you're done. That's where the difference of 2 squares comes in. Okay, but they have to match, and if you don't trust yourself and you just want to go ahead and multiply it all out, go for it. You'll end up with this answer. This just can make things a little bit quicker. So looking at here, 3a squared, 5 plus minus plus. So it just means you take the first times the first. Okay, the middle terms will drop out, so then you just have to do the last times the last. Will that always be a subtraction? Yes, it will. In your answer, always. Because you're always going to be taking a minus times a positive. So let's do another one. Here, 5, 2w, 2w, plus minus. Now, again, you can multiply. If you want to use the distributive property, 5 times everything, 2w times everything. Combine your like terms, and you'll notice those middle ones drop out. First times the first, minus last times the last. And you're done. All right, so that's one of our special cases. It's called the difference of 2 squares. And what happens is in the next chapter, we're going to go backwards. So when you recognize it, it kind of helps to get it to look like this again. Our other one has to do with these squareds. And so if you have a squared, I mean, there's formulas that you can, there are formulas here to follow if you want to, but it's just 2 more formulas to memorize for later on. So I recommend that when you're given this squared, you just write it out twice, because that's what that squared means. I'm multiplying 2 of those. And use your distributive property or your FOIL, and you'll always get it right. So I would just multiply these. You're welcome to follow the formulas if you want to, but here you can take x times, using your FOIL, x times x, outside 3x, inside 3x, which gives you 6x. Last times the last is plus 9. People make a mistake and they just want to square the x and square the 3 and they're done. But that's not correct. This is the correct answer. You've got to have that 6x in there. So again, you can, there are different ways of doing these. If you wanted to follow the formulas, this is the A and this is the B. So you would square the A, then you'll have 2 when you multiply these. So you multiply them and get 7x times 2 is 14x. And then you add, then you have a plus the b squared. You can use the formulas. Now, if you're using the formula, you have a minus, it just changes that middle term to a minus. The last term will always be positive. But again, I just, sometimes I think if you've got this squared, it's just a lot easier just to write it out twice and just use your FOIL or your distributive property. Okay. All right. So that's those. And again, so many people make a mistake with this squared and they end up with no middle term. So again, make sure that you rewrite it twice so that you don't forget the middle term. It's easy just to write x squared plus 9. All righty. So I didn't put any of these in your homework. I took those out. So again, it's just practice. And, using your distributive property, here, I recommend that you just write it out and either use your distributive or the FOIL. But then, this one isn't too bad. If you recognize this, it'll just be x squared minus 9. You have no middle term when they're equal but opposite. You could think of it that way. Alrighty, well, that pretty much does it for this next section. This video was so much shorter than the last one. All right. If you have any questions, please let me know. All right, bye-bye.